I should give everyone warning.
Awesome. Okay, so I am going to actually mute this tab for just a moment. It's not because I don't want to hear people asking questions, but just the doorbell sound is going to drive me crazy if I am interrupted every time. So I'm going to mute this, and then I'll come back and unmute it in a minute. But you can still hear me? Okay. So the talk is preventing errors with TypeScript. And the motto here is that the types should work for you. We're not working to serve the types. Like, the goal is not to add a whole bunch of annotations for their own sake. They should be useful to us. So prerequisites for this talk, you should know no, you don't need to know anything about TypeScript. It will be useful if you've heard of TypeScript, and to have a good working knowledge of JavaScript or a similar language. But we're not going to assume too much knowledge of TypeScript. At the same time, we're not going to start with the basics of, like, this is the whole idea. So if I were to summarize it, TypeScript is, we're adding compile time types to JavaScript, and we're adding a step where the TypeScript compiler is going to walk through and be like, does this make sense? Does this make sense? Are we trying to add a string and a number? Is that nonsense? So that's kind of the goal. And our hope whenever we're adding types is that it's going to be a way for, it's a form of communication. We're communicating with our future selves to try and catch errors before they happen. Our goals for today are not to learn TypeScript entirely. There's some pretty deep pieces of TypeScript, or even pieces that are not all that advanced and deep, that we're totally going to avoid. I don't think there's a little bit about generics at the very end, and I think we'll probably run out of time before we get there. Generics are a super big part of how I write TypeScript, but we are not going to use them very much. We are going to learn specific patterns to use in your TypeScript. So we're going to learn about type annotations and when they're appropriate. We're going to learn that few things are just strings. Most of them have some context around them. So, like, a string might be an ID for some database row. It probably isn't, like, you wouldn't want to accept the entire contents of Romeo and Juliet in a string where you're expecting like a UUID or something like that. There's a pattern called exhaustiveness checking that I find really handy. I'm gonna unmute this tab in case folks want to ask questions, because hopefully everyone's here. It's about 5 minutes in. And this is a bit fiddly. We'll explain more about it when we get to that piece of the presentation. But we're going to learn how to bridge compile time and runtime using type guards. And finally, we're going to learn to love red squigglies. So one of my main goals for this project is to communicate, or to share, really, how fun and pleasant it is to work with TypeScript, and it's like having someone looking over your shoulder and being like, oh, that might be a misspelling. You know what? I think you may be thinking there's a name property, but it's actually a different, like, it's actually title. And just someone, like, offering suggestions very gently the whole time you're coding. One of the ways I think about TypeScript is that it's all about moving. So errors that happen during production are expensive. We want to move those earlier. Can we have them happen during staging? Can we have them discovered during QA? Can we write unit tests for them? And then moving all the way to the left, even earlier than writing a unit test, is, can it be prevented at the time you're just typing out the code? Like, can I get a warning that I might be making a mistake that early in my development workflow? So I'm going to talk a lot about feedback loops, or like the length of a feedback cycle. We want to make that feedback cycle as short as possible. Because if it takes us 20 minutes before we learn we made an error, then we don't make as much progress. We have to constantly be going back and fixing things, as opposed to fixing the mistakes as we make them. So starting off, how to think about types. Types are sets. They're sets of what values are allowed for a given value. So they can be infinite. A string, a value that's of type string, might have any number of things inside of it. They might be finite. A Boolean can only have 2 things in it. And typically, we want to use the smallest set that makes sense. So for an example of this, we're going to look at sort by age. So this is probably not quite large enough. So we have, oh, I said it was sort by age, but I'm sorting by name. I must have changed my mind. So we're sorting this by name. This is some fairly straightforward code. But rather than saying we have an array of any here, I think I forgot to put a mistake in here. Oh, well. Rather than saying we have an array of any here, we should say I have an array we're going to define a new interface. It's going to be a named thing. And it's anything that has a string name. So rather than saying I might have an array of anything at all, we are going to say, define a much tighter type that contains only the properties we need. So when we're sorting by name, we don't care if it was any. I should have put an error. We're not prevented from having misspellings, from accidentally sorting part of it by age. If we use a tighter type that more concretely describes specifically what we're looking for, we get red squigglies. Ah, did you misspell this? Did you actually mean use the age property? And we don't always, when TypeScript flags an error, it doesn't mean like make the red squiggly go away. It's trying to draw our attention to say, something's not matching up. You said we were only going to have name available, but you're using age. Did you mean to add age? Like maybe the problem was with the types. Sometimes the problem is with the code using the type. So another example, we're going to use temperature. So I think we'll go ahead and run this. We're going to use a tool called TS Node throughout this. Make the terminal bigger. Can I get a thumbs up? Is this legible, or do I need to make the text larger? I'm seeing some thumbs up. I only have 8 people showing, so those lucky 8 people got to weigh in, and everybody else is hidden. So TS Node is going to first compile and then run our code. TypeScript doesn't slow down your code any, but it's going to look like it does during this presentation because we're waiting for it to compile. That just in an actual project, we would have a compile step that was probably ongoing. We'd be doing like a compile with the -- watch flag so that it's constantly updating. And then you don't notice it. But rather than mess with a whole bunch of extra files, we're just going to use TS Node. We'll just have to be patient. So we have this function, consider temperature. The units are Celsius, if the units are Fahrenheit. But then when we ask it how it feels about 45 degrees C, which is a reasonable guess for how you might write Celsius, it's just going to respond with undefined. So there's two lessons we can learn here. We said units was a string, but we don't actually want any string at all, right? We don't want to consider the temperature with like the script of the movie Mean Girls in this position. What we should do instead is we should define a tighter type, a more specific type that's temp units, and it's allowed to be Celsius or Fahrenheit. And if we say, rather than any old string at all, we're talking about temp units, we're going to get the red squiggly right where we want it. Argument of type C is not assignable to parameter of type temp units. So we got an error at runtime. We probably could have caught that with a test too. Although maybe not, because it's not a bug in this code necessarily. It's instead a problem with how we're using it. So that may not even be caught by a unit test. It's not the type of thing we would consider. But right now, we've made this function a lot easier to use. So the other thing that's kind of nice is we are going to get autocomplete here. So it's going to prompt me for what the correct value to put in is. If we rerun this, it should tell us that 45 degrees Celsius is really hot. Let me pause and ask for questions here. Okay. Yeah, thanks, Nicole. Feel free to send the questions in chat. I have that open on my other screen, so it should pop up. Next types, nest types. So 2 questions in the chat. Ted wants to know, what's the difference between a type and an interface? It's complicated. Don't worry too hard about it. You can really use either one. There's certain criteria where you have to use a type and certain where you have to use an interface. The main one is that if you have an interface like as name, you can extend that. Interface student extends has name with graduation year. And now student is going to have all the properties of has name and the ones you added right here. You can't extend a type, or there's different syntax for extending a type. You can think of a type as kind of like a type alias. Like the type here is not temp units. Temp units is just a name we're giving to the type, which is actually the set of values, the string Celsius and the string, or the string Fahrenheit. I think even people who've been using TypeScript for like a long time are still, there's still disagreement about when to use type, when to use interface. They probably should have used the same name for both of them. You don't have to worry too hard about it. So the other question, can you nest types? You can absolutely nest types. And we'll see some examples of that in a bit. Oops, I lost temp units. Okay. So what's the advantage to defining string type literals instead of an enum? Totally. So I was anticipating someone asking this question. It is, TypeScript has an enum. Let's comment out temp units here. We can say Celsius, Fahrenheit, and then when we use it, we have to index things off of the enum. For me, like, this is great. I don't have much of a problem to it. I think the autocomplete behavior is slightly better with the union of string literals. There's an article that I'll put in chat from this Tuality site, Dr. Axel Rauschmeier, who's I think on the standards committee, who goes over a whole bunch of ways to do enums. It's unfortunately a bit of a ugly corner of TypeScript. You can absolutely do your enums like this. It's great. There's a pattern that is, in my opinion, conclusively better, but it's a lot more complicated. I'm just doing it like this during the presentation. I'm happy to talk about it after the presentation. Ooh, we've got another good question. If TypeScript is an abstraction on top of ECMAScript and is also a compiler, is TypeScript a sandwich? Cool. That seems like it's very up for interpretation. I'll leave it to the group. Everyone can make their own conclusions. So when we're learning TypeScript, a lot of people focus on type annotations. You can say, if this is the JavaScript, this is the TypeScript. And I kind of hate that because like TypeScript can already tell that if we're defining something as false, it's a Boolean. It knows it's a Boolean. We haven't gained anything by adding these type annotations. My philosophy on type annotations is to use type annotations, but not too much, mostly in function signatures. So we're going to see an example of that in isPrime. So isPrime is a pretty straightforward prime test. We're going to check 2 as a special case because it's the only even one. We're going to start at 3, take steps of 2 up until we get to the largest possible divisor. If any of those divides the candidate, return false. The content of the code isn't too important. I just want to point out, if we start throwing annotations on here, it doesn't really buy us anything. We're not going to catch any extra errors. It just makes our code more verbose. Where we really do want annotations is on our function signature. So a function signature represents a contract, in my opinion, between what must be provided to the arguments and what the function will return. And when we use types to document that more of that contract, that's how it is that TypeScript is going to be able to infer. Like if I hover over this, it can tell that it's Boolean. It doesn't need me to add the annotation. So there are times when we'll add annotations in the middle of functions, but we always want them in signatures, and we don't often need them anywhere else. Like putting them on our function signatures is enough, usually. Great. So, and sorry, just to set the stage a little bit for what the plan is for this presentation, we're going to spend the first bit learning these patterns, and then we're going to go to some code that type checks perfectly, and it's full of bugs. And we're going to apply all of these patterns to fix up that code and kind of resolve those issues and show how we could have written TypeScript that would have warned us when we were making those mistakes. So exhaustiveness checking this is the first pattern where it really clicked for me. I was like, whoa, this is great. This is exactly the kind of reminder that I have been wanting. Some other thing to cover for me. So if we go back to temperature, oh, and I'd better change this back to Celsius. Suppose we add a case to the possible temp units. And right here, this is very obvious what the mistake is. Like, we added the case to the allowed types, but we haven't added a branch for it in the function. But it's not too difficult to imagine that these might be a lot farther apart. There's a project I worked on for NREL where we were drawing floor plans of buildings, and some components that you might want to place inside a floor plan were like daylight sensors, windows, doors, a handful of other things. And we would frequently add a new component type, and there's a whole bunch of places we needed to update. We needed to update the drawing code that presents it. It drew it in a little SVG. We needed to update some code that translated it into a schema for exporting. We needed to update like a whole bunch of other places that handled, like, let me make sure I take care of every possible case of component. So what we want is a way for TypeScript to yell at us if we've forgotten one of the cases that we were supposed to handle. So the first thing we can do is we can follow our own advice from the previous slide and annotate the return here. So if I annotate the return and say that this always should return a string, I'm going to get yelled at because this function lacks an ending return statement. So there is a case where it doesn't return a string. So that's the initial help, but it doesn't give us a very precise error. It's like, if I read that, I'm not totally sure what the fix is. I mean, I guess I can add, like, I don't know, but we'd like to do better than that. So what we can do is, there's a utility that we wrote over here called assert unreachable. This is something I found in a blog post and have been carrying around from project to project ever since. But TypeScript has a special type. Remember when we said types are sets? Never is the type that is the empty set. No value is acceptable for this position. X can't take on any allowed values. So if control ever reaches a place where there would be a value left inside X, TypeScript is going to yell at us. So we're going to import that function. And down here, we're going to say assert unreachable. We should have covered every case in units. And because we didn't, we're going to get yelled at. There's an argument of type string, in particular, Kelvin, that's not assignable to type never. So now we can add that case. So if we say else if units is, and it's going to let us autocomplete because that's the only one left. Oh boy, somebody help me out. I don't actually know. We're just going to return for Kelvin. I can't. Remember, what is it, 273? We'll just go with that. Okay. So now it's also flagging that this is unreachable code because you said we're never going to reach this case. So we don't need the final return statement. And this string annotation is going to, or the contractual agreement that we will always return a string from this function is upheld without a return statement in the final, at the very bottom. Adam, you look confused. What's going on?
I'm good, don't worry.
Cool. So to pause for questions from people other than Adam.
That's just my resting confused face.
Ethan says, what are your opinions on strict flags? The stricter the better. If you're starting from a greenfield project, definitely turn them all on. If you are adopting TypeScript in a JavaScript problem, turn them all off for now. Like, you don't need to be yelled at. What you really don't want is to spend a month converting everything to TypeScript and not making any progress on your code. Like, the types work for you, you don't work for them. So if you are trying to adopt TypeScript on a project that's currently JavaScript and the strict flags are causing you problems, turn them all off. Make it as lenient as you like, just like you would if you were adopting a new linter, and you're going to set the bar really low so that it's easy to adopt. And then over time, you can start writing code that raises the bar and fix those strict flags. I will say that without strict null checks, you lose a lot of the benefits of TypeScript. So it should be a goal to move in a direction where you are able to turn those on. Strict null checks means if strict null checks is off, there's an implicit understanding that every value could be null or undefined, and it's okay. So when you write number, you're really saying it's a number, but it might also be null. It might also be undefined. Strict null checks are a big part of the value of TypeScript, in my opinion. So you want to turn them on as soon as you can, but don't make it painful. Whitney asked to show the code for assert unreachable again. So yeah, it's a bit weird. The main important thing is that we're assigning x to a never variable. We could have done the same thing by saying by assigning to a variable right at this position. But this is really inscrutable. It's super weird. It's not self-documenting, but it does do the same thing. If we added a new unit that's like, I don't know, capsaicin, it's going to yell at us in the same way, or in a similar way, it looks like. But what it's not going to do is it doesn't document the reason we're assigning to this variable that we never use. So assert unreachable is just kind of a way of wrapping this up and saying, here's why I'm assigning to a never. Does that help, Whitney?
Yeah, I guess I was just unfamiliar with the entire word of never used as a type.
Yeah, so never is I think it's called the bottom type. It's the type that doesn't allow for any values at all.
Gotcha.
And then it has a runtime behavior because remember that TypeScript only runs at compile time. It could, if our assumptions were broken earlier in the code, we might be saying that this should be unreachable, but I can actually do anything I want if I lie to the compiler. Like I can pass in bananas and say that it's a temp unit. And if we remove capsaicin here, this is Did we really need the assert unreachable? Let's see what's different. Yeah, so this goes without, or compiles without any problems. But at runtime, it's going to throw that error. So that's the reason for having an error inside here, is it's like all the types said we were never going to reach this case, but you lied to the compiler, and it's going to get its revenge. Okay. So type guards are useful when you want to convert a broader type to a narrower one. Let's go to type guards. And I have lifted these examples straight out of the TypeScript documentation. So if we have a function print ID, and some of our IDs are maybe UUIDs and some of them are numbers, we can't call to uppercase on string or number because that's not a function that's allowed for numbers. So if this is really what we want to do, we break it out into cases. We say if type of ID is string, so even though out here, ID could be a string or a number at the time we're making this comparison, within the if statement, TypeScript is smart enough to say, oh, if at runtime we learned that the type of ID was string, then anything inside this branch is going to be a narrower thing. It must be to uppercase. I'm sorry, it must be a string, and therefore we can use to uppercase on it. Another example is we have a function that accepts either an array of strings or just a string. If we do a runtime check that to see whether X is an array, then even though outside it's either a single string or an array of strings, within this if statement, it must be an array of strings because that's the contract of array.isArray. And then within here, in the else clause, it's going to tell us that it's only a string. So ternary statements are also cool. Yeah, so we should be able to say console.log type of ID is string, then ID.to uppercase, otherwise just ID. That's the kind of thing you were thinking, Ethan?
Yep.
Cool. Yeah, that's shorter. So in addition to type of, array.isArray, you can do instance of checks. You can do, that's mostly it. There might be a couple others in there. But what is kind of, this is a really confusing part for a lot of people because there's two things going on here. There's a compiler behavior that says it is okay to call x.join here because we know it's an array, or it is okay to call id.to uppercase here because we know it's a string within this branch. There's also a runtime behavior that is going to like ensure that as long as ID started out as one of these two things, we are like faithfully upholding that. So that I think of type guards as bridging the runtime and compile time worlds. So over in compiler land, TypeScript wants to make sure we're only calling methods that are really defined. But in runtime land, we need to make sure that the tests we're running to check to narrow those types are actually going to narrow the types. So there's a handful of those built in. And then we can also define our own. So that's the next example. If we look at user input, whoops, should uncomment this. I'll do it one piece at a time. I've been reading the Name of the Wind trilogy recently. So this example is like with from the university there. So imagine we have some API and we have some blob of JSON coming in. Ben says it's bold to call it a trilogy because there's no word on when the third book is coming out. So if we have some blob of JSON coming in, that represents a hole in our type system. Like there's, as far as we know so far, there is no way to make assertion or to make claims about the data someone sends you over your API. Like that's just not something you can't possibly know at compile time. So what we'd like to do is come up with a way to test, does this data match all our expectations? And we want to do that at the boundaries. So we have, I think of within TypeScript, we have this bubble where all the types are correct and everything is sound and it all plays nicely together and we get autocomplete and we can't have any runtime errors if we're doing everything correctly. But outside is the real world where someone can just throw us like an array of numbers when we were supposed to get an object representing a student. So if this is the type that we're hoping to get, we have a department that is one of these strings. There is a course that specifies what department it's in, what course reference number it has, the name of the course. A student has a name, they have an array of courses, and they have an anticipated graduation. So the good data matches all of those expectations. The bad data is close, but the course is missing its course reference number. And instead of anticipated graduation, we have expected graduation. Spring is uppercase. The year is a string instead of a number. Like it's not quite right. So we need a type guard. And what we'd really like is to be able to do something like if good data instance of student. Like, wouldn't that be great? Unfortunately, because TypeScript is like hacked on top of JavaScript, it goes away once we compile. Like it doesn't exist anymore at runtime. So student only exists at compile time. Good data only exists at runtime. And so there's no way we can perform this check the way we have it written. So the built-in way to do this is gross. We would write a bunch of functions. First, we'd write one. This is called a custom type guard. So a way that we can say, if you have some value that's either unknown or any, we can refine it to tell you whether or not it's a department. So the truth, just like type of told us when we had, let me go back to that example. Just like when we started with a union of string or number, type of is going to narrow that type and tell us, oh, within this branch, we only have strings. We'd like to write a test that says, that can be used to say, within this branch, we only have departments, and then outside is everything else. Crucially, there's no checking, really, inside this code. We can lie and say that everything is a department. And that's not going to be a super interesting one for department, but if we turn on the course one, and we say everything is a course, then if we say if bananas const x is bananas, if is course x dot courses at 0. Oh, it is a course. So instead it's going to have a department, x dot department. And it's even going to autocomplete. And if we run this, x is going to be bananas, is course is going to return true, and TypeScript is going to say, sure, you can ask for the department of bananas. Like maybe it's in the fruit section, but that's not really what we meant. And it's because we lied in our type guard. We had our user-defined type guard and we lied in it. If you lie to the compiler, it will get its revenge. So type guards are kind of tricky to write. They're tedious, and if you make a mistake, then you're violating some of the assumptions TypeScript makes when it says your code is probably going to be safe. I went through and wrote these up ahead of time because they just suck to write. Like C has to be truthy. because we're going to be accessing some properties on it. So we're not going to accept null or undefined. Its department property should be, oh, we don't need these anymore. Its department property should be a department, the way we've defined it up here. Its CRN property should be a string, its name, blah, blah, blah. Really unfun to write. This one's even worse because it has that nested object. But it does work. So if we turn these things on and we run, oops, a user input, good data is a student, bad data is not a student. So we've bridged the compile time only types that we are using to get good autocomplete and to make sure the code inside of our boundaries are safe. We've bridged that with the runtime only data that couldn't possibly be available at compile time. I mean, in this case, it could, but we're using JSON parse to pretend that it's coming in from an API. So any questions about what I'm talking about with that bridge? Or, oh, it looks like there are some questions I haven't gotten to. Oh, it's just about the books.
I have one real quick, Brian. You had mentioned that that was not the way to do it because it's such a pain. Are you going to show us a better way? Or is that just what we have to accept?
I'm so glad you asked. Yeah, so there is, in fact, a better way. I'm going to go ahead and copy or comment out all of this stuff. I'm also going to comment out all the types up here. So the other thing, it's not just that those were tedious, it's also a bunch of duplication. Like we are completely describing the shape that we want for student twice. We're doing it once when we define the interface and once when we define the type guard. Wouldn't it be nice, a minute ago we said, wouldn't it be nice if we could say, if good data instance of student? Well, the trick is we can't make the types available at runtime because that's one of the tenets of TypeScript is the type stuff all compiles away. But we can have a representation of like a validator object that turns into, that's made available at compile time. And there's a library called Zod that I'm a big fan of that helps us with that. So up earlier, I'm going to copy this down. We said that type was a union of strings. If we use Zod, we're going to say that it's a z.enum. And I don't want to get into the string versus enum thing again, but Zod's enums are actually unions of strings. But then the real trick, and this is like, this library is super cool, is that even though this is a runtime object, this is a value. You can see we're defining it using const. It's going to be available in our, like in the JavaScript, not just the TypeScript. We can create a type based on it using this z.infer thing. And if we hover over the type, it looks identical to the one that we made by hand. So rather than try and make our interfaces available at runtime, we're making our runtime, these are called schemas, available at compile time. So let's define a couple more. But it's not quite as pretty. Like the code has to be valid JavaScript, so it doesn't come out quite as pretty as the interface business that TypeScript lets us do. But we're reducing this duplication. And in my opinion, this is worth it. So now on these schema objects, we have access to a parse function that might throw an error if the data doesn't match the schema, and a safe parse that just always returns. And within these branches, if this returned a success, and we have access to goodstudent.data, which is shaped like a student. And we get all the normal autocomplete business that we would like. We can ask the anticipated graduation date, ask the year, ask the quarter, hover over quarter. It's going to tell us these are the possible options. And then what is even nicer is when something is not a student. Like, remember earlier, we ran this and we just said, the Ambrose data, not a student. What kind of an API response is that? Like, if someone sends you some data and you say, I don't think so, where do you go from there? Like, that's not actionable. We'd much prefer to give them back, here is the specific key that is wrong. We wanted one of these values and you gave us this, or we're missing a required property. So by defining the schema at runtime, and we could probably have done that if we spent just a ton of time on these custom type guards, but we can get it basically for free if we're using this Zod library. So let's run this again. The first thing it should tell us is that the good data is a student. And then it's going to tell us that bad data is not a student. And then we can log out all the problems, all the errors in the structure that make it not a student. So we were expecting a string, but we got undefined at courses, position 0, course reference number. It's a missing property. We were expecting an object for an anticipated graduation, but we got undefined. If we wanted, there's an option you can turn on that will yell at it about extra properties too, because remember, instead of anticipated graduation, Ambrose has an expected graduation. Let me pause here and ask questions. Ask 4 questions. Okay. So if you have been using TypeScript and you're trying to do something like, maybe you've written a bunch of types, but when data comes in, you just cross your fingers and hope that everything was sent correctly from the client, I really encourage you to try using Zod. They've got a bunch of cool stuff in there also. Let me bring this window over. They have something like ecosystem. They've got this thing called Zod endpoints, where you can define, I haven't tried this one yet, but you can define what are the endpoints available within your API. What methods do they accept? Like this one accepts a schema shaped like a project, and it responds with something shaped like this. And then you get a server, you get type safety between the server and client, kind of not quite for free because there's a bit of work to set it up. The other thing that's kind of cool is you can get this like fancy open API schema from the same thing. So you've made your Zod schema the single source of truth for the types on the client, the types on the server, and the documentation. That's kind of some cool stuff. All right. We have made it to the live coding, and we're going to run right out of time here. But let's just see what we can get done. So if we start with this function that is going to translate some code for us, or translate between languages for us. And we go down to the main section. It should work okay. Let's go ahead and run it to see what goes wrong. Notice we've got no red squigglies. There's not any in sight. We've got no red squigglies. We're basically following all the rules, and yet we're going to get a runtime error. Oh, did I give it away? Throw new error, couldn't translate Pollo to English. All right, so I know I scrolled through this code really fast. Let's see if we can go up to where that error is thrown. Couldn't translate word to lang. What's going wrong here? Anyone shout it out? Here's the error. Here's the call site. I'll go ahead and say
English versus EN.
English versus EN. Yeah, thanks, Kyle. So we said the toLang can be any string at all. And really, we're accepting a much smaller category of strings. So let's give this a name. Supported lang is English or Spanish. And now, oh, and then we also have to say this thing is a supported lang. So then if we go down here, it's going to yell at us right away. Argument of type, the literal string English is not assignable there. So I think it only does autocomplete if there's nothing following it. But now we get the nice autocomplete. We can finish off the line. We're also getting an error over here because we said the API accepts any string. And then we're trying to pass off that string as a supported language. So we better change it in this interface also. So I think that should work. Cool. It translated pollo to chicken, and I don't know why it's hanging. I know why it's hanging. This is what happens when you're making changes right up until the presentation starts. All right, we're just going to comment this bit out. Cool, so now it exits. What else can we do? Say we add another case. And we try and translate it. What's going to go wrong here? Let's run it. Couldn't translate chicken to DE. So we added it to supported lang, but we didn't add a case for it. So how do we fix that? What was the example when we saw that last? Cool. AJ's saying assert unreachable in the chat. Assert unreachable on toLang. Whoops, not toolbar. I don't know where that came from. And it's going to tell us you forgot about the German case. I think I did something wrong. Chicken auf Deutsch. Oh, I know what I did wrong. The German function is wrong. I think we're running out of time to fix all of these if we want to offer time for questions. But I think that's still a good bit. The next things we could have done are we were going to go over to the console and learn about type assertions. So if we, I think I've broken this sufficiently that we're not going to want to do that. Let's go back to the slides. So if you want to learn more, the TypeScript handbook, just like the docs from the project, are really good. They take you on a pretty good tour. There's another book that mostly I read through when it comes up in like search results for how to do things, called TypeScript Deep Dive. That Zod library that I recommend, even if you're experienced with TypeScript, is really nice, and it has great documentation. All the code samples from today are up on GitHub. I'll send out this link in the chat. Thanks so much for coming, and I'll hang out here if people have any questions.
Thanks, Brian.
Thank you.
Thank you.
Thanks.
Cool. All right, thanks everybody. I'm going to go ahead and stop presenting. And I'll talk to everybody later.